Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ibn Irfan bin Muhammad Yusuf, and today I want to share my result of the experiment T1 steam pressure curve of saturated steam. Introduction. So, the heat initially causes water molecules to evaporate. This causes the pressure in the steam chamber and thus in the water to rise. As the steam pressure rises, the boiling point temperature also increases. This is because the water molecules encounter increased resistance as they attempt to move from liquid to gas form. Consequently, each steam pressure has an accompanying precisely defined boiling point temperature. So this is all about molecules trying to break the van der Waals faults so that it could change from liquid to gas. So this is because of the presence of heat. Objectives. There are two objectives on why we conduct the experiment. First is to investigate and study the relationship between the pressure and temperature of saturated steam in equilibrium. Second is to demonstrate and show the vapor pressure curve. Right. Now we go on to the apparatus. So there are 18 components that makes up the Marcet boiler. This is what we call Marcet boiler, right? So procedure. So first is to perform the startup procedure. Second is to switch on the main power supply. Third is to switch on the heater, and we have to make sure that the water is ready to boil. Third, next is to close the valve as the temperature reaches 60 degrees Celsius. Then we have to take the reading of the temperature, or we have to take the obtained data. Uh, we have to record the data obtained. Next is to turn off the heater as soon as the reading is at 10 bar, and we have to perform the shutdown procedure. To give a better look to get a better look at the procedure, right? First is we have to perform the quick inspection for the startup procedure. We have to perform quick inspection so that we can make sure that the apparatus is in good condition. Next is we have to connect the unit to the power supply, or else how will this apparatus function. Then we have to open specific valves, MVB 101, MVB 102, MVB 103, and MVB 104. Then we have to make sure the water is at half or more than the tank height. If the tank is filled, close valves MVB 101 and MVB 103. Shutdown procedure. So shutdown procedure is what we have to do as to finish the experiment at the end of the experiment. So there are 5 steps. First is to switch off heater and leave vessel to cool down. Second, switch off the main power supply after boiler reaches room temperature. Third, retain water for next experiment. And then we have to open valve MVB102 to release water. As soon as we are finished with that, we can soon go on to the last step, which is to open valve MVB104 and MVB105 to drain water from tank. Is to give a even better look. Here, perform startup, switch on power supply, switch tank power and wait boiling process. close valve 102 and reaches 60 degree, take reading and you turn the heater off. So safety measures is what we have to keep in mind or what we have to do in order to make sure that we are being kept safe during experiment. Okay? We always have to dress properly. We always have to keep area clean, wash our hands, and we do not eat in the lab. And may any troubles come up, we always have to ask for assistance from the lab supervisor or our lecturers. Okay, so let me give an example. Dress properly. Always wear your lab coat. Always wear closed-toe shoes or boots. Always wear your gloves. Always wear your goggles, and like keep the area clean, so that we won't be tripping over anything such as bags or maybe loose items in the laboratory. So the calculation here is my example of my calculation to calculate the errors. Since this experiment does not require any use of equations or specific calculations, so I decided to add my work of calculation of errors together. This is my sample of calculation. So speed up the video, where the equation is experimental value minus theoretical value, and the answer will be divided by theoretical value. So what I did there is 119.3 minus 99.61 divided by 99.61, and that will be times by 100. So I did that, the error is 90.77%. So okay, before I go on, this is the thermodynamics property table. I'm using table A5 to calculate the theoretical pressure by looking at the pressure given there. Okay, and I will soon get its temperature. So presentation of data. This is the table I've drawn. So here is the gauge pressure, absolute pressure, temperature, and temperature from the property table. Moving on, plotting of graph. This is how I come up with my graph. So I did a simple table there that includes absolute pressure, experimental temperature in degrees Celsius, and also theoretical temperature, which is also in degrees Celsius. Give it a minute there. So I'll just fill in the blanks there with the values, the certain values. So what I'm going to do after this is to create a chart, and I'm using a line bar. So that's the chart that yes, I'm going to make the chart more presentable by putting in titles, putting in values. So like what I did there is the plotted graph of data. It's both experimental and theoretical temperature against the absolute temperature. And as a proof that this is mine, that's my name and my matrix ID. So this is the graph there, the final graph. So as a conclusion, after studying the results and plotting the graph, the relationship between pressure and temperature has been obtained where it is directly proportional. The relationship of saturated steam in equilibrium water is the higher the pressure of a boiler, the more heat must be applied to make the steam. With the increased pressure, it tends to get steam. Okay, so here is an industrial steamer which uses the concept of Marcet boiler, similar to what we have just experimented with. So I think that is all from me. Thank you for lending me your ears and your time. Assalamualaikum warahmatullahi wabarakatuh, and thank you.